Hello and welcome back to MechZone. Today in this lecture we shall be solving 20 best problems in fluid mechanics and fluid machinery. All the problems that we are going to solve in this lecture are highly probabilistic to be asked in GATE 2019 or the upcoming examinations for 2019. So I would like to request you to kindly watch this video till the last and try to follow up all the problems that have been solved here. So before starting this lecture, I would simply like to request you that if you have not subscribed to our channel yet, kindly do so by hitting the subscription button and also press the bell icon so that कोई भी important update अगर हमारे चैनल पर होता है तो आपके पास सबसे पहले पहुंच सके। और जैसा कि आप सबको पता है कि हमारी वेबसाइट भी लॉन्च हो चुकी है www.mechzone.co.in, जहां से आप हमारे नोट्स दैट इज बेसिक कोर्सेज और बॉन्साई कोर्सेज को बाय कर सकते हैं। यू कैन यूज द कोड MZ3733 ताकि आपको अच्छा खासा डिस्काउंट भी मिल जाए। और हमारे पेन ड्राइव कोर्सेज जो है वो अगस्त से लॉन्च होंगे। इसमें दो ऑप्शन रखे गए हैं उनके लिए कि जो सिर्फ और सिर्फ पेन ड्राइव चाहते हैं उनके लिए भी ऑप्शन है, या जो सिर्फ पेन ड्राइव के साथ नोट्स भी अगर उन्हें चाहिए तो वो भी ऑप्शन हमारे पास अवेलेबल है। सो लेट अस स्टार्ट विद द फर्स्ट प्रॉब्लम ऑफ द डे एंड वी हैव बीन गिवन दैट it is a type of a match the column type question. We have three types of fluid machines like Pelton wheel, Francis and Kaplan turbine, and four options have been given: medium discharge, low head, high discharge, low head, medium discharge, medium head, low discharge, high head. So we have to match the column. We have to match list 1 with list 2. So if we see A, that is the Pelton wheel with a single jet, is actually a low discharge and high head. So A becomes 4. Now let us go for the Francis turbine, and Francis turbine is actually a medium head, medium discharge turbine. So B is actually 3. And Kaplan turbine, that is C, it is a high discharge, low head turbine. So C is 2. So the correct option that we have here is D. Next question is a question from hydrostatic forces, and in this question we have been given the following: shows a rectangular high board AB which is pivoted at C. The maximum height of C above B so that the flashboard will be on the verge of tipping when the water is at O will be. Now for the condition of verge of tipping, the center of pressure must be located at C. So the center of pressure must be located at C. Now height of C above B. Height of C above B would be nothing but 9.5 divided by 3, and this is 3.16 meter. Okay, it would be 3.16 meter. And for a rectangular plane surface of height h just completely inside the fluid, the center of pressure is actually at a distance of h by 3 from the base. तो बेस से h by 3 डिस्टेंस पर हमारा होता है सेंटर ऑफ प्रेशर फॉर अ रेक्टेंगुलर प्लेन सरफेस विच हैज जस्ट कंप्लीटली इनसाइड द फ्लूइड. सो द आंसर इज 3.16 मीटर. सो ये भी क्वेश्चन बहुत सिंपल था, सिर्फ एक लाइन का क्वेश्चन है, तो ये भी क्वेश्चन काफी प्रोबेबिलिस्टिक है कि हमसे पूछा जा सकता है. नाउ द नेक्स्ट क्वेश्चन दैट वी हैव: a capillary depression of mercury 20 degrees centigrade per comes out to be 4.2 mm in 2.5 mm diameter tube. The surface tension has been given. The contact angle will be. Now we know that the height, that the capillary height or the rise or depression formula is given by 4 sigma cos theta upon rho g d. So here we have to find out the value of cos theta. So it is a case of depression. Since this is a case of depression, we will keep h as minus 4.2 into 10 to the power minus 3 meter. So let us try to keep all the values. We have 4.2 into 10 to the power minus 3. This would be equals to 4 into 450 4 1 cos theta divided by 13.6 multiplied by 1000 for the density of mercury multiplied by 9.81. We will keep the value of G as 9.81 into 2.5 into 10 to the power minus 3. So from here theta is coming out to be 140.467 degree. So this is the answer. So we need to directly remember the formula of H is equals to 4 sigma cos theta upon rho g d. Now let us try to attempt the next question, and it has been given a piston of 7.95 diameter and 30 centimeter long works in a cylinder of 8 centimeter diameter. The annular space is filled with oil of viscosity 3 poise. If the axial load is this much, the speed of the piston will be. Now the force on the piston would be equal to the shear force due to viscosity. Force on piston, it would be equal to shear force due to viscosity. Shear force due to viscosity. तो ये इस तरीके से स्टेट कुछ इमेजिन करिए, ये एक सिलेंडर है, उसके अंदर दूसरा सिलेंडर ऑपरेट कर रहा है, और ये जो हमारा स्पेस है, दिस हैज़ बीन फिल्ड विद एन ऑयल ऑफ विस्कोसिटी 0.3 पॉइज. ठीक है, तो जो हमारा 18 हो जाएगा दैट वुड बी इक्वल्स टू टाउ इनटू ए, और टाउ आपको पता है म्यू वी बाय एच होता है. एरिया हो जाएगा पाई डी एल इन केस ऑफ cylinder. So 18 would be equals to 3 into 0.1 into the velocity that we have to calculate into pi into d. D has been given as 7.95 centimeter. So we will convert it into meters first, because the velocity, or we can report the velocity in meter per second itself. So it would be 0.0795 multiplied by L. Length has been given as 30 centimeters, so we will keep it in meter, and therefore it is 0.3 meter, sorry, 3 into 10 to the power minus 1 meter. And H is actually the gap which has been given as, yes, gap we can easily calculate by 8 minus 7.95, so it would be 0.025 into 10 to the power minus 2. So from here, if you find velocity is coming out to be 0.2001 meters per second, or we can even express it in centimeters, so it would be nearly equals to 20 centimeter per second. So this is the answer. Now in the next question we have been asked the vorticity, that is omega x, at the point 111 for the flow field u is equals to 2x square plus 3y, v is equals to minus 2xy plus 3y square plus 3zy, w is equals to 3 by 2 z square plus 2xy minus 9y square z will be. Now we know that omega at x, this is nothing but del w by del y minus del v by del z. This formula I have already discussed in my lecture, so you can refer to the lectures of fluid mechanics on my channel Megzone, YouTube पर आप देख सकते हैं. तो यहाँ से जब हम इसे सॉल्व करेंगे तो यह जाएगा माइनस 18yz minus 3y. So if we will calculate this at the point 111, then it will come out to be minus 21 units. So the vorticity at the point 111 is coming out to be minus 21 units. Now in the next question we have a low speed wind tunnel is provided with the air supply up to a velocity of 150 meter per second at 20 degrees centigrade. there is a need to study the behavior of the boundary layer over the flat plate kept inside the wind tunnel up to the Reynolds number 10 to the power 8. The transition occurs at 3.5 into 10 to the power 5 Reynolds number. 25 degrees centigrade, viscosity of air is 15.7 into 10 to the power minus 6 meters square per second. What is the minimum plate length that must be used for the study? So for the minimum plate length, we will use the Reynolds number, that is RE, it is equals to rho VD upon mu, or we can also write it as VD upon nu. So here diameter नहीं लेंगे, यहाँ पर हम लोग length ले लेंगे, तो VL upon nu. So Reynolds number has been given as 10 to the power 8. This would be equals to V into L. V has been given as 150. Let us assume that the length is L and nu has been given as 15.7 into 10 to the power minus 6. So from here the length can be evaluated as 10.466 meter. So this is the answer. So we generally have to remember the formula for Reynolds number here. Now in the next question that we have, for a steady fully developed flow inside a straight pipe of the diameter 1 meter, neglecting gravity effects, the pressure drop is 50 kilopascal over a length of 100 meter. The wall shear stress would be, now we will directly use the formula tau wall is equals to delta PD upon 4L. So this is a direct formula that we'll be using here. So delta P is given as 50 kilopascal. So we will convert it into Pascal, multiplied by diameter is given as 1 meter and 4 into length has been given as 100 meter. So this would be 125 newtons per meter square. So this is also a direct formula to find out the wall shear stress, which can be used here. Now the next question that we have, Prandtl mixing length in turbulent flow signifies. ये क्या signify करता है Prandtl length? So it is nothing but it is the average distance perpendicular to the mean flow covered by the mixing particles. So you can view my lectures on YouTube, where I have completely explained about Prandtl's mixing length and everything. It has been covered there. So this is just a theory question. Now in the next question that we have, a container with two circular vertical tubes of diameter D1 equals to 39.5 and D2 equals 12.7 is partially filled with mercury. The equilibrium level of the liquid shown on the left diagram. A cylindrical object made from the solid brass is placed in the larger tube so that it floats, shown in the diagram. Object is D, object ये जो है D is equals to 37.5 millimeter in diameter and height is 76.2 mm high. What will be the new equilibrium level H of the mercury with the brass cylinder in place? Now since the cylinder object is floating in the mercury, we can have the weight of cylinder would be equal to the weight of mercury displaced. Weight of cylinder would be equal to the weight of mercury displaced. Weight of cylinder would be equal to the weight of the mercury displaced for floating condition. Now for the weight of cylinder we have pi by 4 into 0.0375. So this is the diameter, pi by 4 d square into, just a second, तो यहाँ पर एक चीज़ हमें ये नोट करनी है कि जो हमारा ये एडिशनल पार्ट है, यहाँ पर जो हमारा एडिशनल ये जो डेप्थ दिख रही है, लेट दैट डेप्थ बी x। मान लेते हैं हम वो डेप्थ क्या है, x है। ये वाली जो एडिशनल डेप्थ है ये, so let this depth be x, and since we have already seen that the weight of the cylinder would be equal to the weight of the mercury displaced, so we will write pi by 4 d square is 0.0375 d square multiplied by 0.0762 pi by 4 d square into h. This would be the multiplied by 8.55 kg, 8.55 into 9.81, okay, and multiplied by 1000, ठीक है। तो this would be the weight, that is m into g, और m क्या होता है, डेंसिटी इंटू वॉल्यूम, और वॉल्यूम क्या होती है, एरिया इंटू हाइट। तो उससे हमारा ये आ गया, this would be equal to 13.55, that is the rho, multiplied by h plus x, that is this total distance h plus x, into 9.81 multiplied by 1000 multiplied by 0.0375 whole square. So if you solve here, you will get the values of h plus x. This would be equal to 0.048 meter. Now also the volume of the object below the initial level would be equal to the volume of the mercury which is rising above the initial level. Now the second condition will be obtained from this statement that I told you just now, and the statement is the volume of the object below the initial level would be equal to the volume of the mercury which is rising above the level. So let me first erase this matter. Okay, now so this would be obtained as pi by 4 into 0.0375 square into height हो गया x initially, this would be equals to pi by 4 into 0.0395 का square minus 0.0375 का square multiplied by h plus pi by 4 into 0.0127 का square multiplied by h. So from here we will obtain h upon x. This would be equals to 4.46 meters. So यहाँ पर एक इक्वेशन हमारी आई है, this is equals to 0.048 and this is 4.46 meter. So if you will solve, h is coming out to be 0.0392 meter. So this is the answer. So this question is actually from the chapter of buoyancy and flotation. So by using the simple formulas or simple concepts, this question can be solved. Now in the next question that we have been given fluids of viscosity mu1, mu2 and mu3 are contained between the two plates. Each plate is 1 m square in area. Lower plate is fixed. The thickness are h1, h2 and h3 which have been given. The steady speed v of the upper plate due to a force of 100 newtons will be. Now we know that the shear stress tau would be nothing but force upon area. So this would be 100 upon 1 and that is 100 newtons per meter square. Okay, this is 100 newtons per meter square. Now let V12 be the intermediate velocity between the layers 1 and 2 and V2, 3 be the intermediate velocity between the layers 2 and 3. So tau would be equals to mu1 V12 upon H1. So if we keep the values of tau, that is 100, mu1 is 0.15, let V12 is V12 only, and this would be 0.5 into 10 to the power minus 3. So from here V12 would be equals to 0.333 meters per second. Now we can know that tau is equals to mu2 into V23 minus V12, okay, divided by H2. This would be, if we calculate and keep the values, V23 is coming out to be nearly about 0.383 meters per second. Now once again we apply this equation, tau is equals to mu2 into V23 minus V12 divided by H2, just a second, H3, this would be H3. So this is coming out to be 0.2 into V minus 0.383 divided by H2 is 0.2 into 10 to the power minus 3. So from here we can solve that V is coming out to be approximately 0.483 meters per second. So this is the answer. So we simply need to apply only the Newton's law of viscosity, and this Newton's law alone can easily solve the question number this. Okay. Now in the next question we have, it is from the fluid kinematics, and this question says that a flow is described by the stream function psi is equals to 2 root 3 xy. The coordinates of the point at which the velocity vector has a magnitude 4 units and making an angle 150 degree with the x-axis. Now we need to find out the coordinates, and we know that del p upon del t, this can be written as del p upon del x into del x upon del t plus del p upon del y into del y upon del t. Okay. Now for this question, actually I am so sorry, this is not a relevant solution here. Please erase this and let us try to do this question again. Where is the eraser? Okay, eraser not working. So please forget about this. Actually it's a mistake. So psi is been given as 2 root 3 xy, and we know that u is equals to del psi by del y. So this would be equals to 2 root 3 x, and we know that minus del psi by del x, so it is will be minus 2 root 3 y, and the complete velocity would be under root of u square plus v square. So this would be under root of 4 into 3 into x square plus y square. Okay, and we know that tan theta is equals to v upon u. So tan 150, the angle which has been given, this would be equals to minus 2 root 3 y upon 2 root 3 x. So it will be cancelled, and hence we will obtain y is equals to 0.5744 x. Okay. Now what we are going to do is, we already have the values. One value we have obtained from here, this would be equal to 4, and the other value is here, that is y is equals to 0.744 x. So यहाँ पर हम ये value रख देंगे और यहाँ पर जब हम सॉल्व करेंगे तो ये हमें मिल जाएगा y is coming out to be 0.5774 and x is coming out to be 0.999. सो ये कोऑर्डिनेट्स हो गए हमारे, जहाँ पर आपका पॉइंट, ये वो पॉइंट है जहाँ पर वेलोसिटी वेक्टर का मैग्नीट्यूड 4 है, क्योंकि यहाँ पर आपको 4 वेलोसिटी मतलब ये जो मैग्नीट्यूड दिया इट हैज़ बीन गिवन 4, तो इसीलिए वी हैव टेकन हियर एज 4. So this was also an important question. Now this question that we have, we will be using the concept here. So a two-dimensional pressure P is equals to 4x cube minus 2y square is associated with the velocity field given by V is equals to x square minus y square plus xi cap minus 2xy plus yj cap. The rate of change of pressure at the point 2, 1. Now for the rate of change of pressure, that is del P upon del T, we have del P upon del X into del X upon del T plus del P upon del Y into del Y upon del T. So keeping the values, we have 12x square multiplied by x square minus y square plus x plus minus 4y multiplied by minus 2xy plus y. So the rate of change of pressure at the point 2.1 can be simply calculated. If we keep x is equals to 2 and y is equals to 1, then we will obtain, so we will obtain the values. So I'll again write down 12x square x square minus y square plus x plus minus 4y into minus 2xy plus y. So on keeping x is equals to 2, y is equals to 1, the value of del P upon del T, it is coming out to be 260 units. So the answer is 260 units. Sorry, this was, I think, yes, this was the question and I have solved it in the previous slide. So please forgive me. So the answer for this particular question, it is nothing but del P upon del T is coming out to be 260 units. Okay. Now the next question that we have is a very simple question, and it has been given the velocity at the point 3, 3 for the stream function psi has been given as minus x ln xy plus x will be. So we know that u is equals to del psi by del psi by del y, that would be equals to minus x into 1 upon xy into x. So u at 3, 3, if we will evaluate, it is coming out to be minus 1 meters per second. Now v is equals to minus del psi by del x. So this is coming out to be minus 1 minus x into 1 upon xy plus y, sorry, multiplied by y plus ln xy into x minus 1 plus 1. Okay, so v at the point, this is nothing but simply we have to differentiate by using the uv rule. Okay, so v at the point 3, 3 is nothing but 1 plus ln line minus 1, this is 2.197, and we know that the velocity magnitude vector v would be under root of u square plus v square. So the final answer that we will obtain is 2.41 meters per second. So this is the answer. तो यहाँ पर जो हमारी वेलोसिटी की वैल्यू आ रही है, इट इज़ कमिंग आउट टू बी 2.41 मीटर्स पर सेकेंड. नाउ लेट अस अटेम्प्ट द नेक्स्ट क्वेश्चन. A tapering pipe has a diameter of 25 centimeter at a point 1, elevation 25 meter, and the diameter of 35 centimeter at the point 2, elevation 20 meter. The pressure at the point 1 is given and the point 2 is also given. Discharge is given. The kinetic energy correction factors are alpha 1 and alpha 2 for the sections 1 and 2 are 1.1 and 1.5 respectively. We need to find out the loss in head through the pipe. So let us draw the pipe. Say this section is section number 1 and this section is section number 2. Okay, so here the elevation Z has been given as 25 meter Z1 and here Z2 has been given as 20 meter. The diameter here has been given as 25 centimeter and the diameter here has been given as how much? 35 centimeter. Okay, now velocity at the point 1, it would be equals to Q upon area. Q has been given as, that is the discharge has been given as 0.2. Area is pi by 4 d square, so pi by 4 into diameter will be taken in meters, d square. So velocity here is 4.075 meter per second. Now velocity at the point 2 would be Q upon area 2. I will write 1 here. So if you calculate, this is coming out to be 2.079 meters per second. Now alpha 1 has been given as 1.1 and alpha 2 has been given as 1.5. So let h1 is the loss of head. So हम मान लेते हैं h1 loss of head है. तो अब हम क्या करेंगे, अब हम अप्लाई करेंगे बर्नौलीज इक्वेशन. सो बर्नौलीज इक्वेशन P1 अपॉन रो जी प्लस अल्फा 1 इंटू V1 स्क्वायर अपॉन 2G, अल्फा 1 मल्टीप्लाई कर देंगे प्लस Z1. दिस वुड बी इक्वल्स टू P2 अपॉन रो जी प्लस अल्फा 2 इंटू V2 स्क्वायर अपॉन 2G प्लस Z2. सो ये हो गई हमारी बर्नौलीज इक्वेशन. अब हम इसमें वैल्यूज पुट कर देंगे. बस हमें क्या ध्यान रखना है, प्रेशर इज 120 किलो पास्कल. तो किलो पास्कल से हम उसे पास्कल में कन्वर्ट कर लेंगे. तो ये हो जाएगा 120 इंटू 1000 डिवाइडेड बाय 1000 इंटू 9.81 प्लस अल्फा इज 1.1 मल्टीप्लाइड बाय 4.074 square divided by 2 into 9.81 plus Z1 has been given as 25 meters. This would be equal to P2. P2 is 172.45 into 1000 into this divided by 1000 into 9.81 plus alpha 2 has been given as 1.5 into V2 we have already calculated as 2.079 V2 square upon 2 into 9.81 Z2 प्लस यहाँ पर H1 और आ जाएगा जो हमें फाइंड करना है प्लस H1. So if we solve this equation, the value of H1 is nearly coming out to be 0.2531 meter. So this is the answer. Now in the next question we have oil of relative density 0.9 flows at the rate of 10 liters per second and through a horizontal pipe of 7.5 centimeter diameter. The pressure drop over a length of 300 meters of the pipe is found to be 40 Newton per centimeter square. The viscosity of the oil is assuming a laminar flow. So we know that Q is equals to area into velocity. So Q has been given as 10 liters per second. So we will convert it into meter per second. So 10 into 10 to the power minus 3. Area would be pi by 4 into d square. D would be 0.075 whole square. मीटर में कन्वर्ट कर लेंगे मल्टीप्लाइड बाय velocity. तो यहाँ से जब हम वेलोसिटी सॉल्व करेंगे इट इज़ कमिंग आउट टू बी 2.2635 मीटर पर सेकेंड, and we know that delta P is equals to 32 mu VL upon D square. So यहाँ से अगर आप mu की वैल्यू फाइंड आउट करना चाहें तो इट इज़ कमिंग आउट टू बी 0.1035 पास्कल सेकेंड। ठीक है, बस हमें ध्यान ये रखना है कि प्रेशर जो डेल्टा P है इट वुड बी इक्वल्स टू 40 इंटू 10 टू द पावर 4। ये सेंटीमीटर स्क्वायर को मीटर स्क्वायर में हम लोग चेंज कर लेंगे। सो द आंसर इज कमिंग आउट टू बी 0.1035 पास्कल सेकेंड। नाउ द नेक्स्ट क्वेश्चन, कंसिडर लैमिनार फ्लो ऑफ वाटर over a plate of length 1 meter. The ratio of the boundary layer thickness at the point A and B is √3. Moreover, the sum of the distances of point A and B from the leading edge is equal to the length of the plate. The distance XA and XB from the leading edge would be. So I will draw the diagram of the plate first. This has been the plate. This is point A. This is point B. This is the entire length, that is 1 meter. Okay, this is XA. Okay, now we know that the length of the boundary layer is directly proportional to the under root x. So delta B upon delta A, this would be equal to √3, which has been given. So now delta B upon delta A would be equals to under root XB upon XA. This is equals to √3. So we can have XB would be equals to 3 times XA, and XB plus XA, this is equals to 1. So we will solve, we have two equations and we will solve them simultaneously. X is coming out to be 0.25, XB is coming out to be 0.75 meters. So this question is important question. इस टाइप का क्वेश्चन भी हमारे एग्जाम में आ सकता है. Now in the next question we have a fluid of dynamic viscosity 2 into 10 to the power 5, 10 to the power minus 5 kg meter per second, and density has been given. Okay, density has also been given. So flows with an average velocity of 1 meter per second through a long duct having a cross-sectional area of an equilateral triangle of side 25 mm. Assuming the laminar flow, the pressure drop. Now the pressure drop formula, delta P, I have already told you, 32 mu UL upon D square. Now the D, that is the diameter for this equilateral triangular duct, would be 4 into area upon perimeter. 4 into area is √3 into A square. A जो side हो जाएगा 0.025 मीटर का square divided by perimeter. Perimeter would be 4 into 3 into 0.025. तो यहाँ से जो हमारा D कैरेक्टरिस्टिक डायमेंशन आ जाएगा इसका 0.0144 मीटर. ओके, तो यहाँ पर ये 4 एक्चुअली नहीं होगा, ये बाय मिस्टेक मैंने लगा दिया है, तो ये 4 नहीं होगा यहाँ पे. पेरीमीटर वुड बी सिंपली 3 into the side, and the diameter D is coming out to be 0.05773 meter, and we will keep these values as 32. Mu has been given as 2 into 10 to the power minus 5. Let us as the velocity has been given as 1. Length L has been given as 32 mu U L. One second, fluid diagram. Okay, so upon D square. Okay, so जो लेंथ है L, तो यहाँ पे दिया हुआ है पर मीटर लेंथ. ठीक है, तो पर मीटर मतलब हमें सिर्फ 1 मीटर के लिए ही लेना है, तो लेंथ भी हो जाएगी हमारी 1. अपॉन डी स्क्वायर 0.057735 का स्क्वायर. So the answer which is coming out is 0.192 यूनिट्स. ये हो गया हमारा आंसर. तो बस हमें एक चीज़ यहाँ ध्यान रखनी है कि कैरेक्टरिस्टिक डायमेंशन फॉर अ इक्विलैटरल ट्रायंगुलर डक्ट वुड बी 4 into एरिया अपॉन पेरीमीटर. Okay, now the next question that we have is actually from the models and prototypes dimensional analysis. We have a large hydraulic turbine is to generate 300 kilowatt at 100 rpm under head of 40 meter. For testing 1:4 scale model of the turbine operates under head of 10 meter. The power generated by the model would be. Now for the similar turbine, the specific power is Nm dm upon under root hm would be equals to n of the prototype d of the prototype upon under root h of the prototype. Now n of the model, it has been given as 1000. It has been given as 1000 rpm. So now for the same specific speed, now if they are having the same specific speed, then we have n model under root p model divided by hm की power 5/4. This would be equal to n of the prototype under root p of the prototype upon h of the prototype e power 5/2. Now we need to calculate the power of the model, and in order to calculate the power of the model, so here we have a correction, and the correction is the Nm, that is the value of n for the model. It is coming out to be, this I have solved wrong, because the ratio this has been given as 1:4. So Nm into 1, because for model it has been given as 1 and head of the model has been given as 10, so we will write under root 10. This is equals to n of the prototype that has been given as 1000 into dimensions of the prototype are 4, because the ratio is 1:4, divided by head of the prototype is given as 40, so under root 40. So from here Nm is coming out to be 2000 rpm. Now this 2000 rpm will be substituted here, and the value that we have to calculate, yes, the value of Pm, that is the power by the model, it is coming out to be 2.34 kilowatts. So this is the answer. Okay, now let us attempt the next question. We have been given a sphere of 609.5 mm radius, floats half submerged in salt water. The minimum mass of concrete that has to be used in order to anchor, to be used as an anchor to submerge the sphere completely will be. Now in the first case the sphere is floating like this, but now we need the mass of the anchor which is to be attached to this sphere so that it is completely submerged. So this would be the level of water. Now radius has been given as 0.6095 meter, and let the mass of the anchor that is to be used here is small m. So initial weight of the sphere would be calculated as by 2, 4/3 pi r cube into density of the salt water has been given as 1025 kg per meter cube multiplied by g. Okay, so it is this. Now when the mass m has been added, it would be W plus mg would be equals to 4 by 3 into pi r cube plus m upon 2403 multiplied by 1025 g. So where r is the radius of the sphere, so on solving this question we will obtain m is equals to 847.10 kg. So this much mass of the concrete is required to completely submerge the sphere. Now in this particular question, it is from the capillary height or capillary fall, and if the surface tension of water has been given, the correction needed to be applied towards the capillary rise in the manometric tubes of 2 mm diameter. We know that H is equals to 4 sigma cos theta upon rho g d. So 4 sigma cos theta upon rho g d. Here we will substitute the values that we already know. So H would be 4 sigma has been given as 0.075 cos theta would be 1 because it is for water, upon rho is 1000, g is 9.81, and diameter will be 2.5 into 10 to the power minus 3 meter. Now from here H is equals to 0.0122232 meter, or this is 12.23 millimeter. So rise in the manometric reading is actually 12.23 mm. So the correction that would be required is minus 12.23 mm. So the correction that would be required will be minus 12.23 mm. So with this we come to the end of this particular lecture, in which we have solved 20 very good problems on fluid mechanics, and I hope that you people have really enjoyed it and find it useful for your preparation. So I would like to request you all कि आप हमारे चैनल को सब्सक्राइब कर लीजिए, और हमारी वेबसाइट से आप सारे नोट्स को परचेज़ कर सकते हैं. जो भी नोट्स आपको लेक्चर्स में दिख रहे होंगे एग्जैक्टली वही नोट्स आपको हमारे वेबसाइट से बाय कर सकते हैं, बेसिक कोर्सेज और बॉन्जाई कोर्सेज के फॉर्म में. और प्लीज़ यूज़ द कोड ऑफ MZ3733 टू अवेल द exciting discounts on our products. So thank you so much, and do subscribe to our channel.